How do you solve an inequality? For example, x plus 2 is greater than negative 3. You solve an inequality very much the same way as you would solve any algebraic equation. The goal is to isolate x, or get x by itself. Right now we're adding 2 to x, so we need to subtract 2 from both sides of the equation. We can write x plus 2 minus 2 is greater than negative 3 minus 2. Positive 2 and negative 2 add to 0, so they will cancel. That leaves us with x is greater than negative 3 minus 2, and that evaluates to negative 5. So the solution to this inequality is x is any value greater than negative 5. So let's see what that would look like on a number line. We locate negative 5 on the number line and draw an open circle to show that negative 5 is not included in the solution. The solution would be all numbers greater than negative 5. And then we draw an arrow to the right to show that our solution is all numbers greater than negative 5. What I like to do once I solve an inequality is to choose a number in my solution set and plug it into the original inequality. For example, if x can be any number greater than negative 5, then x equals 6 should make the inequality true. So let's test it. We're going to plug in 6 for x in the original inequality. 6 plus 2 should be greater than negative 3. 6 plus 2 equals positive 8, and positive 8 is greater than negative 3. So that's a true statement. So we solved this inequality correctly. Let's try another example. This time we have negative 4 times x is less than or equal to 12. Our goal, once again, is to isolate x, or get x by itself. Right now we're multiplying x by negative 4, so we need to divide each side of the equation by negative 4. So we can write negative 4x divided by negative 4 is less than or equal to 12 divided by negative 4. Negative 4 divided by negative 4 gives us positive 1, so all we're left with on the left side is x. On the right-hand side, we have 12 divided by negative 4. That equals negative 3. Since we divided each side of our inequality by a negative value, we have to reverse the inequality sign. So we're going to write x is greater than or equal to negative 3. Whenever you divide or multiply your inequality by a negative value, you must reverse the sign. So our solution is x is greater than or equal to negative 3. Let's see what that looks like on a number line. We locate negative 3 on the number line, and this time we're going to use a closed circle. And that's because x could equal negative 3. It doesn't have to just be greater than negative 3. It could actually have the value of negative 3. So we're going to include that number in our solution set. And since x is greater than or equal to negative 3, we're going to draw our arrow to the right of negative 3. And now let's test our solution. We're going to choose a value that's greater than or equal to negative 3. So this time let's test negative 2. We can rewrite the inequality, negative 4x is less than or equal to 12. And this time we're going to substitute negative 2 for x. Negative 4 times negative 2 is less than or equal to 12. Negative 4 times negative 2 is positive 8. 8 is less than or equal to 12. Well, 8 is less than 12. So this inequality evaluates to true, which means we solved it correctly. Now let's solve a two-step inequality. Negative 2x minus 1 is greater than or equal to 9. Our goal, once again, is to get x by itself. So our first step will be to add 1 to each side of the inequality. And that'll give us negative 2x minus 1 plus 1 is greater than or equal to 9 plus 1. Negative 1 and positive 1 add to 0, so we'll cancel them out. And that leaves us with negative 2x on the left side of the inequality. That's going to be greater than or equal to 9 plus 1, which is 10. Our next step is to divide each side by negative 2. That leaves us with x on the left side of the inequality and negative 5 on the right side of the inequality. And since we're dividing by a negative value, we have to reverse the inequality. So we're going to write less than or equal to. So the solution to this inequality is x is less than or equal to negative 5. Now we can graph it on a number line. We're going to look for negative 5, and we're going to draw a filled circle. And that's because x could be equal to negative 5. So negative 5 is part of the solution set. X can also be less than negative 5, so we're going to draw an arrow pointing to the left of negative 5 to show that the solution set is all numbers smaller than or equal to negative 5. So now let's test our solution. If we plug negative 8 into our original inequality, it should evaluate to be true. So let's test it. We can write negative 2 times negative 8 minus 1 is greater than or equal to 9. Negative 2 times negative 8 is positive 16. Positive 16 minus 1 must be greater than or equal to 9. Positive 16 minus 1 is positive 15. And positive 15 is greater than 9. So this is a true statement, and that means we solved the inequality correctly.